Okay, now we're to the point, machine set up, pipe has been closed up. This is when we're going to turn our attention back to the data logger and start that process. What do we do to start a fusion? Hit the giant start button, and now we're on that job summary screen. From here, there's a few things that we want to select, and these are things that you're going to do right when you get onto site or the start of the project. You're not going to do every fusion. You'd quickly move on to the next screen. In this case, we're doing pipe fusion. We do have the option to do pressure testing with the data logger, but that just diverts that process for subsequent screens. Joint ID, that's something you can key in yourself or whatever the start of that project is. In this case, we're just starting with joint number 1. The job, the operator, the machine, all very important. So job, this is something that is typically predefined before the project, whether it's a work order number, a specific street name, or project name. Those all need to be set up ahead of time so that the operator knows exactly what they need to enter, because that data is all going to be fed into the vault under that heading of that job name. The operators, so these, best practice, get all your operators who could be operating that equipment set up ahead of time before it goes to the field. That way it comes to a simple selection of that operator for whoever's running the piece of equipment. Spell out the job name or the operator names exactly how you want them to be. Include some sort of ID number, whether it's a company ID number, an association ID number, but something you can tie them back to, especially when it comes to that OQ perspective. But then we'll quickly set up, select our operator, and then our machines along the same lines of the operator. We want to include, what is the type of equipment, because the data logger will actually, pull up the TIPA for that fusion calculation. You also want to record those serial numbers and attach them to that machine as well, and then provide a unique name for the machine. So this would be something like an asset number, something that you can quickly identify, especially if you had multiple pieces of the same equipment. You want to be able to say, oh, this is that one. In this case, our asset number is TCA153. That's the name of this equipment. I can quickly identify it here and move on. We also have some additional flags. And I always say the data logger, from a technician perspective, I'm building a story. I'm showing my work. I'm building that story for whether it's the inspector, a manager, pipeline owner, whoever it may be. So we have some additional fields here. Am I using an in-ditch kit, or am I doing a tie-in? Because those things can play into that fusion graph, and we're sharing or giving that notification to that end user who's going to consume that information. Hey, this is what we're doing, and we want to show you that this is why you may see some anomalies. You also have access to the operator's manual. So whether you need maintenance information or operation information, you have that electronically on the data logger for the machine that you have selected as well. But we'll quickly move on to the next screen, and here we have fusion type. So in this case, we're going to be doing butt fusion. We can look and see what else we have. So we do have sidewall, miter, and dual containment as well. One of the bigger ones, probably miter. Good thing to know about miter is you put in your angle, it'll actually calculate that surface area for you so you get to the right fusion pressure. Great little feature there, but we're going to stick with butt fusion. Then I get into the specifications. So we have every major specification used globally in the data logger as well. For certain ones like ASTM F2620, we actually include different years as well, just for whatever was referenced in particular jobs or particular instances. We're going to stay with F2620, and then again, now we're moving on and setup photos. And this is where we would want to document what our setup is. This is really when we're turning our attention back to the data logger. We've done all our work with the setting up the pipe, getting our alignment. Now we want to document that. And what I want to do is I want to show exactly what's going on here. And I want to show that I have good alignment, my high-low, I have no gaps. So I'm going to put this down into facing mode. I don't have any gaps, I have good alignment. I can grab my data logger, and I'm going to take a photo of that. Zoom in there, take a photo, attach that photo. And I'm also documenting the cleanliness of my work area. I'm not showing dirt going all the way to that fusion zone. I don't have shavings laying around that could potentially contaminate this joint. So now we're ready to move on. So we're gonna hit next. So weather conditions. This is great, documenting, again, if you're in hot or a cold environment, what can play into different fusions, especially like windy situations. But here, what we're actually doing is it'll pull in the ambient temperature as well. I'm going to enter a particular pipe temperature. Weather conditions, we have some hotkeys, is it sunny, is it cloudy, whatever it may be. It may not be an impact like it is where we are right now indoors, and I can actually select that type of shelter. I'm actually indoors, I'm in a tent, or I'm outdoors, whatever the case may be. So I'm going to quickly move on. Now we're going to set up our pipe information. So in this case, we're using some 6-inch DR11. So I can quickly select, I can change that, whether I'm using, inches, whether it's metric, whether it's IPS or DIPS. I have all that selection easily input. The wall thickness as well, and then the pipe material. So every major pipe material is also in the data logger for quick selection. This is 4710, and we're fusing like-to-like pipe. So you can also select dissimilar pipe, where if you were fusing different DRs or different production lot numbers as well. And that's where traceability really comes into play. So I have the ability to have traceability information about my materials. I can't stress the importance of this enough. Even if you aren't working with anything that's barcoded, you can manually input the manufacturer, their lot number, or the production date as well. If you are, let's say, in the regulated space where, typically the natural gas industry, we can actually scan that F2897 barcode and import all that data in as well. If you have custom cases, we can certainly accommodate that as well. So we'll quickly move on from our pipe settings. Again, we're building up that information. So we know our standard, we know our machine, and then we know the pipe that we're fusing. And part of this standard is we have our interfacial pressures. So ASTM is 60 to 90 PSI interfacial. We're targeting right in that middle at 75. It can be adjusted, again, a little more advanced situations. And then we get into measuring our drag pressure. So I have my machine set up. I'm gonna switch back. I'm gonna pull it out about 1.5 inches, 2 inches away. And I'm gonna shift into my heat soak. I'm gonna back my valve all the way out. I'm reading pressure. Then I'm gonna start to close, and I'm gonna dial it up. So I can't get any more out of that. You back that up one more time. I can't get it any lower, so I'm gonna let it go. I'm gonna dial up that pressure, and I'm gonna hit measure drag. And that's exactly where my drag is gonna be. We have it at 24 PSI, and then I can move on. And again, this is a big calculator. So now it has actually taken all those elements, plus now my drag, and told me what I need to set up my fusion pressure as. So now I'm gonna switch down into fusion pressure. I'm gonna close that, let it go up. It's a little over, so I'm gonna back that off. Try to get it right about that 205 mark. And again, and you just wanna get it close. So we're right there. Our machine's set up. So our drag pressure set up, or our heat soak pressure, and our fusion pressure. So now we've prepared our machine. Remember that guided workflow, set up photos, documenting what pipe you're using, measuring your drag, preparing your machine, and then now the next instance would be measuring our heater. So we can record multiple temperature points. In this case, we have it set up just to record one point, and we can record on both sides of that heater plate. So what we're gonna do is we're gonna take our heater. In this case, we're actually using a cold heater just for demonstration purposes, but I'm gonna record that heater plate temperature on both sides, keep it in the bag, and then I can come over, touch the side that I need. I'm gonna say we're at 425, then I can flip the plate as well, record the other side, and now I have both of those recorded. My heater's in the bag ready to go, temperatures are going, and now I'm ready to start.